So today we're going to finish up section 7.5, solving our square root and radical equations. Today the only difference is that we're going to have variables on both sides. We'll also have sometimes problems where we have multiple square roots or multiple things being raised to rational powers. Now when we see problems like this, you'll notice the directions change. They don't just say solve. They also say check for extraneous solutions. So it's no longer optional to check, you now have to check, because some of these will be extraneous. Remember, extraneous mean extra solutions that are not actually solutions. So when we solve this and square and do all this stuff, we are kind of modifying it a little bit, the equation. So sometimes we get almost fake answers that aren't really solutions to the final. So when we're solving these, we're going to do basically the same thing as we did yesterday. We want to isolate the radical on one side of the equal sign. So I would start by using inverse operations and subtract 3 from both sides. Then I will raise each side to its appropriate power. So to get rid of a square root, I'm going to square both sides. Now on the right hand side, beware, because we do have a binomial being squared. So the square and the square root, those undo one another because they're inverse operations to leave me with just the radicand, what's under the radical, 5x minus 1. What do I have to do whenever I square a binomial? What do I have to do whenever I square a binomial? Lainey? Expand it. Exactly. And then we're going to have to FOIL after that. So this will become x minus 3 times the quantity x minus 3. You cannot just square each term because of the subtraction, also if there were an addition. So now we'll FOIL. And we'll get x squared minus 3x minus 3x is minus 6x. And plus 9. Now you'll notice we have a quadratic term. And normally when we solve a quadratic, we really learned 5 ways to solve quadratics. But one of them was factoring. So remember the warm-up from yesterday we solved by factoring. So in order to factor, we need to get this in standard form. So at this point, I'm going to get the equation set equal to 0. That way it's in standard form and I can solve by factoring. So I will move the 5x and the negative 1 over using inverse. So I would subtract 5x and also add 1. So that these go to become 0. And we have x squared minus 11x plus 10. So now we have a quadratic trinomial, which is factorable. So from here, we're going to factor into 2 binomials to get 2 answers. We're looking for numbers, 2 numbers that multiply to 10 and add to negative 11, so minus 10 and minus 1. Then we use our zero product property to get the 2 answers. Setting each one equal to 0, and using inverse to solve. So adding 10 to both sides, we'll get 10. It's 1 answer. And adding 1 to both sides, we'll get 1. Now, I would venture to guess about 90% of the time, one of these will be extraneous. Okay, so about 10% of the time, both of them will work. There is also the chance that neither of them could work, and we could get a no solution type equation, but we do have to check each of these. So I'm going to show the check by hand on this one. Remember, when you check, you do want to make sure that you plug into the original. Okay? So let's check the first one. And you can do this, a lot of it mentally, guys. You don't have to show every single step for the check. So I'm plugging in 10. So 5 times 10 is 50. So I'm going to put the square root of 50 minus 1 plus 3 equals x, which x we're plugging in 10. We have to do one at a time. And then we'll do this in our head. 50 minus 1 is 49. The square root of 49 is 7. And 7 plus 3 is 10. So 10 is most definitely a solution. Okay, to check the next one, we're going to plug in 1. So I'll get 5 times 1 is 5 minus 1 plus 3 should equal x, which again, x is 1. So 5 minus 1 is 4. The square root of 4 is 2. And 2 plus 3 is 5, which does not equal 1. Thank you, Bailey. So because these are not equal, that means this is an extraneous solution. So you literally get rid of it. Do not leave it down there. You want to cross it out because it is no longer a solution. So it shouldn't be circled as our finals. If you want, you could wait to circle them at the end and then only circle the answers that exist. Okay. On Monday, I'm also going to show you how you can use the graphing calculator and your y equals button to actually graph both sides of the equation. And you can look for the intersection, which will also show the solutions. So number 9, also similar. We're going to get our radical by itself. So I just kind of cover up my symbol, so that's a minus. So I'm going to use inverse to add 3 to both sides. Take the inverse of a square root, which is to square both sides. Again, we need to expand the right-hand side. So we'll make that 2x plus 3 times the quantity 2x plus 3, and we will FOIL. So we will get 4x squared plus 6x plus 6x, which is 12x, and plus 9. Again, we need to get it set equal to 0 before we're allowed to factor. So I will move these over by subtracting x and subtracting 2. Now, this is a harder factoring problem because the a variable, the ax squared plus bx plus c, is not 1. So this is our guess and check or trial and error method. So whenever I go to factor this, again, I'm going to think of what would multiply to get me 4x squared. I could either put 4x and 1x or 2x and 2x. Okay, there's no really surefire way to know which one is which, but when I look at this, I notice that 4 plus 7 will get me 11. So I'm going to try 4x and 1x first. Okay. Now in the other two terms, factors of 7 are just 7 and 1. Now if I put this 7 here and I FOIL, I'm going to get 28x, which is really big. So I want to put the 7 in the other slot and the 1 here, and then we have to check it by FOILing. Really just checking the O and the I part. So we'll get 7x plus 4x, which is 11x. Okay, so this one is a little bit harder in the factoring department. Now we use our zero product property, so we're still going to set each of these equal to 0, which the first one is going to take 2 steps instead of just 1. So we can't just say it's negative 7. We have to subtract 7 and divide by 4. So we'll get x equals negative 7 fourths as one answer. And the other one you just subtract 1, so that's negative 1 as our other answer. Now, you can check these by hand, but whenever you have a fraction or a decimal with a radical, sometimes you'll end up having to rationalize the denominator and a whole bunch of stuff, so it can get kind of time consuming. So let's try checking this in the graphing calculator. I'm hoping this will show up on my recording also. Now, when you input this into the calculator, you're going to type in as you see, but remember the negative 7 fourths is going to get parentheses. You could also change this to a decimal if we wanted to, but I'm going to leave it to show how you can always do it for fractions. that may be repeating. So I'll type in the square root, so second x squared. Now it puts a parenthesis, except for the new calculator. So we're going to put another parenthesis to plug in the x value. So I'm going to do another parenthesis, negative 7 divided by 4, close the parenthesis, that's my x value. Then we're going to add 2 to that. Now I'm going to close the parenthesis to indicate that the radical is now done. Okay, because they always put an open one after the radical, and you need to close it. Or you'll just hit the arrow over button. And then we're going to type in our minus 3. Now you can't type in the other side of the equal sign at the same time. You have to do it in 2 separate lines. So hit enter, we get negative 2.5. Now we'll type in the other side, which would be 2 times negative 7/4. And we're hoping these are the same number. They're not. Okay? So basically, if we were doing the check, we would end up getting negative 2.5 equals negative 3.5, which it does not equal, therefore we get rid of that answer. That's extraneous. When you do the same thing for negative 1, so we'll press square root of, you don't have to put parentheses around the negative 1, I just normally do, because sometimes it's safer. And then we'll subtract 3. I get negative 2. Now the other part you can do in your head, 2 times negative 1 is negative 2. But if you want to have it in the calculator so that you can see it, like you get the same exact answer, then that one does check. So that is my solution. Okay. Now the next one looks different than the others because it has 2 radicals. Okay, you do not want to square right off the bat. Hello? Hi. Okay. That's fine. Okay. Bye. All right, so I was saying you don't want to square this right away because then you're going to end up having to actually FOIL with big square roots, okay, because of the subtraction sign. So the first thing we would want to do is get the other radical on the other side. So I would add the square root of 2x plus 7 to both sides. Whenever you add that to 0, it just stays the square root of 2x plus 7. Now I will undo a square root by squaring both sides. Those will get rid of the radicals, leaving me with just what's underneath them. And this one is something you're going to like to see. There's no quadratic term, so you don't have to factor this one. We're just going to solve for x. So get our variables on one side, subtract 2x, and isolate the x to get x equals 5. You still need to check this. Even though there's only one answer, you still have to check it. It could be extraneous, and this could be a no solution problem. Okay, so you have to verify. Now, we're checking this in the original, and again, let's do it mentally because 5 is pretty easy number to work with. So 3 times 5 is 15. 15 plus 2 is 17. Minus, the next square root is 2 times 5, which is 10. And 10 plus 7 is also 17. The square root of 17 minus the square root of 17 would be 0. So that one does check out. The last one we'll probably get to today is number 11. Oh, we might have time actually for some more in here since we're at lunch period. These are radicals, don't forget. Okay, remember the denominator is the type of root. So these are really cube roots that we're seeing. We're going to treat these just like we did all of the other ones. We want to get each radical on one side or separate sides. So I would add the 9x plus 1 to the 1/3 power. On both sides. Now yesterday, when we had these rational exponents, what did we do? Brennan? Good. We raised both sides to the reciprocal power, which then multiplied those together. Now the issue is these are different. So if I take the reciprocal of this one, it would be 3/2. The reciprocal of this one is just 3/1. You can't do different things to different sides. It has to be the same thing. So basically you could take the reciprocal of either one and do that. Most students will just want to do the root. So if you pay attention to the denominator, that's the type of root you see. That's a cube root. So let's cube both sides. Just like here we saw a square root, so we squared. So if these are not exactly the same, I would just go ahead and do what's in the denominator and do the reciprocal of that. So I'm going to raise both of these to the third power, or the 3/1 power. If you did the 3/2 power, it'll work out. Okay, but this is just my suggestion. You have to do the same power on both sides. So what will happen is you'll end up getting 6/3, which is still squared. Or you'll also notice that these will kind of divide out. So I'm left with x plus 1 quantity squared. On the other side, the 3's are going to divide out to get me 3/3, which is just 1. So this is really just 9x plus 1 to the first power. So I'm not going to write that. And then we'll solve for x from here. So we have to expand this. We have to FOIL it. So we'll have x squared plus 1x plus 1x is plus 2x. And 1 times 1 is just 1. Again, we need to get it in standard form, set equal to 0, so I would subtract 9x and subtract 1. Now, I'll get positive 1 plus or minus 1 will get me a 0, so I'm not even going to write anything. You could put plus 0 if you want. So this is a quadratic, but it's a binomial instead of a trinomial. How would I factor this one? Summer? Good. You can take out a GCF of x. That's really the only thing you can do. We are still going to use the zero product property, set each of these equal to 0. So one of my answers is x equals 0. The other one would be x minus 7 equals 0. Add 7 to both sides, we'll get positive 7. Now again, you could check this by hand, like plugging back in 0 and taking the cube root and squaring it, taking the cube root and raising it first. If you want to use the calculator to do your checks, just make sure that you do put parentheses around your rational exponents when you type them in. So we would have, plugging in 0, 0 plus 1, caret, parenthesis 2/3, minus parenthesis 9 times 0 plus 1, caret, parenthesis 1 divided by 3 power. Hit enter, and we do get 0, which is what it should equal. So this one checks. And then we would do the same thing with the 7. You can hit second enter and then just go change some of these. Just change the 0s to 7s. On your calculator, it's much easier than up here, because mine always goes too far. And we also get 0. So this is one of the rare cases where both answers do check. We don't have any extraneous answers. We have 2 answers here. Okay. So we are done at, maybe I'll schedule 18. So we have about 4 minutes left. Why don't we try one on the back? If we don't finish it, that's okay. We can at least start it. Jade?
So when they're not the same, we just completely ignore the numerator. We don't do anything.
Well, it did stay there. So whenever I multiplied by the raised to the 3/1 power, the numerator did stay. Now, if you wanted to do the 3/2 power, Jaden, so if you wanted to do the reciprocal power, 3/2, and 3/2, these would cancel to become just x plus 1, but then over here you'd have a square, so a square root. Then you'd have to square both sides again. So it would kind of just take an extra step. But yes, my suggestion to you is if the numerators are different, that you just deal with that, getting rid of that denominator. And this will just kind of follow you through the problem. Great question. That's going to happen in 12 when we get here. So we do see decimal roots, or decimal exponents. So we probably want to change those back to be fractions first. So 0.5 is just 1/2. Remember, you can always do 5/10, because that's in the 10th place, which reduces to b. And then we have minus 3x plus 4. 0.25 would be 25 out of 100, which then is 1/4. And then from here, we again want to get the roots on different sides. Now the denominators are different this time. So we will have to determine which one we want to do. So this time again, the denominators are different. I have a 2 and a 4. Do you think I should square both sides or raise both sides to the 4th power? I want to be able to get rid of the denominator so that I don't have any type of root left. Lainey? Yes, we want to raise both sides to the 4th power. If I were to raise this side to the 2nd power, I would get 2/4, which is still 1/2, which is still a fraction. So you would want to raise to the larger power. And if you choose the wrong one, you'll realize that you still have a radical, and then you'll go back up and change it. So this will get me 4 divided by 2, which is still 2, or squared. The other side, the 4's would undo one another to just be, I don't really need the parentheses then. And then we do need to do all of that work again. So we're going to expand and FOIL. So we'll FOIL the left side to get 4x squared plus 2x is plus 4x plus 1. And then we would keep solving from there. We are running out of time, so I'm not going to finish this problem. I am going to record it later, and then I'll post it with the rest of it, so in case anyone wants to watch it. Your homework is 15 through 30 on the teacher page, so just the rest of that assignment.